without further ado, I'd like to have Steve, Stenio, and Josh come on screen. Welcome. Thank you guys for taking the time to put this together and to schedule some time in your week to come talk to us. And with that, I can't wait to hear about infrastructure as code in 2022, the trends and best practices, and whatever else you have to show for us today. Welcome, gentlemen.
Thanks, Jim. If you don't mind, if you can stop screen sharing, I'll go ahead and share the presentation here, Jim.
I'm working at Google, invested in this because of the ideas behind Terraform being something that can be leveraged across all the different cloud providers. More specifically, think of yourself as an advocate for other teams that you don't directly integrate with. If you think about IaC, well, even if it's on-prem, that terminology and those concepts, if you can share the value of it, you can really help teams that you don't directly integrate with understand the value and then really change your organization to transition to something that you don't have to take 10 weeks to go transition a firewall change on-prem and in the cloud. Through leveraging different types of infrastructure as code, it can all be done in a seamless manner very quickly, especially if you create reusable code that you can very much replicate everywhere. So key benefits, automate. That's a huge aspect that takes away you as that single point of failure inside of your organization, whatever you're working on. Being declarative is something that's very important to understand. Declarative really, in essence, talks about a desired state, meaning it's stateful, not updates. So when I say stateful, I'm not talking about, hey, here's this code version of this application with this OS that's running this code version. I'm talking about the state of this is X, yes or no, it's binary. It's there or it's not there. The principles behind what OS am I running and what code version am I running, that's something that you want to bake into the code prior to leveraging infrastructure as code to deploy it. And we're going to talk about that a little bit more, but just understand that the declarative aspect of infrastructure as code is very important because you want to sit there and try to design with that in mind. The challenges that you run into are, I've deployed all my infrastructure, and then now I have this other team, or now I have security coming in and trying to deploy on top of that. And that's where your configuration drift can start coming in from a code perspective, because something goes bump in the middle of the night, you need to reboot everything. There are some challenges you can run into if you don't have all of that code captured. So other aspects that really create the benefits of infrastructure as code is the validation, desired state, current state. A lot of the ITIL framework talks about where have you tested this. It's great if you're in an environment where you can actually test something to the nth degree inside of a dev and QA environment, but usually infrastructure is lacking. You don't have an exact replica of prod inside of dev and QA, and that creates some challenges. Infrastructure as code can help accommodate those challenges and help not only from just a CAB perspective, which I'm sure as an individual contributor can be like, it's needed, but it's also terrible. This can help with that validation process and help also mitigate that risk, which is ultimately the true value of what an ITIL framework provides. The last piece is modular. And where I really think that to emphasize this aspect is think about modules themselves. Specifically, I am responsible for a certain type of infrastructure. I want to create something that is easily able to be consumed from other teams. And therefore, now I'm no longer that single point of failure. I don't have to go to every team meeting about every project. I can simply say, okay, I've gathered some requirements of what people are doing. Let me build something that's scalable that everybody else can use. And as I get more feedback from different teams, I can then either add on top of that or create new modules. And then ultimately, what am I doing? I'm creating this giant specialized tool set that other developers can leverage, and I don't have to be directly involved with their implementations and their specific changes that they want to make. I can give them a very basic framework that they can run off and start using tomorrow, as opposed to me having to get involved and be there to code it directly. If we could jump to the next slide. So this is a good concept, and Stenio is going to talk a little bit more about this, but remember where I talked about declarative and making sure you're understanding the concepts there. This really ties, it doesn't tie into it. It complements that conversation where we talk about config management versus IaC. Configuration management, that's your OS, that's your patching. It's not really applicable for your native cloud resources. And if you want to sit there and, well, maybe not the case, well, some aspects between cloud resources are more on the SaaS offering than the infrastructure side. But whenever you're talking about the configuration management, it's not always going to be applicable, but just being cognizant of where your delineation is really going to help allow you to become successful where IaC is excelling as opposed to your configuration management. So examples of the configuration management is installing the web server on the VM, not the VM itself, installing the web server on the VM, creating a namespace for GKE cluster, loading data into BigQuery. BigQuery being a managed database that Google provides. And that is kind of a cool concept because it's a gray area. Google's taking care of all of the actual infrastructure pieces, but the data itself is what the customer is responsible for. Now let's take a look at where IaC excels and where it performs. That's going to be the provisioning of the VM. It's going to be the IaC that wraps around the Google API. So whenever an API needs to be called, essentially what IaC does is it makes that call for you, puts it in a human readable format, which makes the documentation easier. It makes the understanding of what is actually being deployed and how it's being deployed easier to troubleshoot, identify, and understand. And then lastly, you're not going to be focused on the package configuration. And where you're like, well, hold on a second. Yeah, I'm going to need a VM, but I also need that package running. Well, that's where we're going to have the conversations around whenever you need to build that package into that instance, create an image off of that. And now you're leveraging just infrastructure as code, but you're also accommodating that package configuration inside of your infrastructure as code. So, and we'll get more into that about the definition of what's called mutable code versus immutable code a little bit later. But this is just to kind of give you the precursor to some of the pieces that we're going to be getting into. We could jump over to the next slide. So IaC tool landscape, we're going to be talking a lot about Terraform. There are absolutely a lot of pieces that if you want to go full native Google, there's a lot of options there. We had a question specifically from Sabre talking about this, and they're like, well, hold on. Google's got stuff. Why are we talking about Terraform? Why is Google talking about Terraform? Google has great features for IaC within the Google platform. The caveat is it only works in Google. So if you're wanting something that's going to scale across multiple environments, and in today's world where some customers only inside this cloud or they're only on-prem, those are kind of days of the past. Now you're looking at that even in a transition, you're going to be in a hybrid environment. So Terraform is something that really complements the dynamic that Google preaches about being agnostic to different clouds. And this is really a showcase of that and being able to say, hey, we have this. If you want to use it, it's awesome. It works. But if you want something that scales across more than just Google, this is where Terraform really plays well. There's also other aspects such as Pulumi and Ansible and Chef. Now, the key pieces with Ansible and Chef is that's where we're looking at more the config management over the infrastructure as code. Pulumi, I think it's a cool product, cool concept. The challenge that I have with Pulumi is it doesn't really have Google support. Another aspect is there's not a free version. And I think that to be successful in today's world, and hey, Pulumi, feel free to prove me wrong, you need to be very cognizant of the adoption. And I have concerns if I'm going to be learning a new language, essentially, is this going to be something that's going to last a large portion of my career? Am I going to have to worry about learning something new in 3 years because it either gets bought out, turns into shelfware, or doesn't get used to the degree that we needed it to for whatever reason? So it really kind of brings us back over to GCP native or Terraform. And if you're in a hybrid environment, I don't see a reason to go native to GCP and then use native AWS configuration tools when you can leverage Terraform, understand the HCL language, which, to be honest, it's kind of like if I had to describe it, very simple YAML, like very human readable YAML is like the easiest way I could describe that programming language. A lot of customers that I've worked with that don't have any coding background, they felt very comfortable with Terraform from the beginning, just looking at the code and being able to piece it together. So that's kind of the IaC tool landscape and kind of leading to where we're going to be spending a lot of time talking about Terraform based off of other different types of landscape for configuration management and the infrastructure as code tool set. So specifically Terraform. Terraform's infrastructure as code is built HashiCorp. It automates building and management of infrastructure, key piece infrastructure, using a declarative language. So there's that declarative word again I keep referencing. So key pieces, multi-cloud. It's also open core with enterprise support. So the idea being Terraform, if you want to deploy it today, you're using the open source. HashiCorp has Terraform Enterprise, which is going to be your licensed version with full support from HashiCorp. So think of that more or less in terms of, I want to use this cool thing because it's free, but oh wait, I have compliance reasons where I'm not allowed to just use open source everything. That's where HashiCorp fills that gap to get you the enterprise support that you're going to need and still enable you to use something that you think is cool and you've been leveraging. It's really successful within your organization. And not only that, but it also has a really large community. Kind of I would define it as a self-fulfilling prophecy. Hey, if you work with all the cloud providers, you're probably gonna have a large community because you have all the cloud providers that are gonna be leveraging you or have the opportunity to at least take a look at your product. So that's a high-level overview of Terraform, specifically around what the key pieces of interest are. So the Terraform support with Google. We have Google actually has a team that helps to, one, maintain any modules that have been developed, as well as publish new modules as well, on top of HashiCorp having their team as well that does the exact same thing. So there are beta provider versions. So if you are trying to experiment with something, and that's kind of a challenge where like, well, this is going to be coming GA, we want to use it, timelines match up, but I don't want to just be clicking through the UI. I want to build this as code up front. That's where the beta provider versions will really come in. And then, of course, you can also open up support cases as well. So the professional services Terraform assets, that's all something that's going to be available via GitHub. And there's an entire platform for that. And it's really cool to look at because it's not only Google and HashiCorp, but it's also users that are like, hey, I built this cool thing. I want to share it with the world. Really catering towards that open source development. There's everything. I mean, I won't go through this whole list, but the idea behind it is if you're looking for something infrastructure as code, that GitHub repo is going to be your best friend. And odds are you're not solving this for the first time. And if you are solving something very specific, odds are you can find 60% of what you're looking for through those modules. And then it's just tacking on the little specifics that you're looking for to solve your exact immediate problem. So. All right, next up, IaC strategy and execution. So I'm gonna pass it over to Stenio, and I'm gonna give a little bit of an introduction. So when Jim first asked me to present this, and I'd done some presentations internally with Google, I said, if you want to become very humble, come work at Google where you think you know something, you're gonna meet somebody who knows it a lot better. And that's where I pinged Stenio. I said, Stenio, I know this stuff, but given that you have a history of working at HashiCorp before Google, I think you would be a very appropriate person to bring to the table for this session, and as well as Josh being with HashiCorp. But without further ado, I'll pass it over to Stenio.
Thank you. So hey everyone, my name is Stenio Ferreira, and like Steve mentioned, I'm a CE at Google. I joined last year, and prior to Google, I was working at HashiCorp for 3 years, where I had the privilege of working with Josh. So it was a great surprise to see him here as well. My part of the presentation, I'm going to give an overview on Terraform itself. So Steve gave an overview of IaC, infrastructure as code in general, and now we're going to make it a little bit more concrete. The only disclaimer is that the content for this presentation usually is given in 4 hours as a workshop, talking about the specifics of Terraform. But for today, I'm going to condense everything. If anybody has questions, we can talk afterwards in the networking session. So this slide is a little bit a repeat of what Steve was talking about regarding Terraform. So open core model, and it fits the requirements of infrastructure as code tool. So you can go ahead, Josh. Like Steve mentioned, Terraform is based on HCL, Hashicorp Configuration Language. His analogy is easier YAML. My analogy is easier JSON. So you don't have the commas, and it's more accommodating, and it's easier to read. It's a declarative language. So instead of having to specify do this, do that, like an iterative approach or imperative approach, you just specify your desired outcome, and Terraform is responsible for executing. Next. So Terraform, using HCL, you're going to describe different objects within your Terraform code. So those objects, they start with the providers. So those are the different platforms that Terraform is going to support. There are resources, there are objects in these platforms, data sources, variables, outputs, and modules. So there's a slide for each one of these. So let's move next. This is an example of the provider code. So a Terraform file is just a text file, and you're going to have these declarations of the different objects. This is an example of declaring the start of a Terraform code for GCP. For Azure will be something similar. And you might be asking, oh, but where do I pass my credentials? The recommended approach is for you to use environment variables, and we're going to talk at the end. This is a very critical aspect, managing your credentials, so you don't push them to GitHub. So save that in your mind, because that's very important. But just providers in general, just one last point there. Most people think that Terraform is just GCP, AWS, Azure, I don't know, Oracle, some other weird cloud, but that's not actually the case. So Terraform supports infrastructure as a service provider, platform as a service, and software as a service. So there are over 800 different providers, and HashiCorp sees infrastructure as not only the platform, but all the different components that your applications need to run within a context. Next. The resources, like I mentioned, once you have identified what's your provider, then you specify what are the different objects that you can create in this provider. So if it's a platform like GCP, it's going to be the VMs, your database, etc. If it's a software as a service, like any object that service provides. Next. And you might start to see there's a pattern in these objects, these blocks. There's the key keywords for Terraform, either resource or provided at the beginning. There's the name of this type of resource, the name of this object within your code, and then the different parameters for this particular object. Data sources are similar to resources, but resources, you're asking Terraform to create something new. Data sources, you're referencing something that already exists. So in this example, we are referencing an image that we assume already exists in the GCP platform. Next. The other point is the variables. So nothing prevents you from creating Terraform code that's completely static. So Terraform, give me a VM in this region with these parameters, and there you go. And that's not a very useful Terraform code. So you start to use variables to allow flexibility in your deployment, and that starts to show the power of Terraform, because you can create your codes, and in theory, you can execute the same code in your development and your staging and production environments, just changing those variables. But the main code remains the same. And finally, the outputs file. It's kind of the opposite of variables. So variables would be the inputs, and outputs is where you can express, once Terraform executes, what's going to output for you. If you're executing in the terminal command line, it's going to output there. For example, if you deploy a VM, Terraform can give you what's the public IP that was assigned for this VM. And the concept of outputs and variables is very important when we start talking about modules. So if you go ahead, Josh, please. So modules is what one of the key aspects that allow the Terraform reuse. So yes, you can just create your Terraform code with your variables and outputs and share within your organization. But eventually you're going to start seeing certain areas of your code that don't change as often. For example, if you're describing a VPC with its subnets and then VMs and then your security groups or whatever, IAM permissions, eventually you might identify that there are certain blocks that you can reuse, especially for your organization's governance. You can start creating certain modules as best practices, and your developers only need to reference these modules. So instead of rewriting the entire code of that particular section, let's say the IAM permissions, they can just reference this code, utilizing the variables to change as needed, and reading the outputs from the outputs. So that's a way that Josh is going to talk about, how when you start thinking of day 2 operations, how to actually manage Terraform within an organization. That's one of the best practices that's recommended. So this is the pattern for Terraform. Usually you're going to write your Terraform code. You're going to set the variables. There are multiple ways of informing Terraform variable values. You're going to execute a plan. That's like a dry run. It's going to give you an estimate. If Terraform were to be executed, this is the expected outcome. And if you think this looks great, you can execute an apply that's actually going to apply that. And eventually, Terraform allows you to destroy, so it keeps track of whatever resources were created in the state file. And then you go to the next slide. So that's one of the most important concepts of Terraform, that yes, it is a declarative language, but it is stateful. So once you declare your desired infrastructure and you execute the Terraform code, Terraform keeps track of what it has deployed in that particular execution. So then whenever you do an update or whenever you want to destroy, it knows how to reference and it knows how to identify if there were changes to the code or changes that perhaps were done manually. So the state file allows you to ensure that the Terraform code remains the source of truth. And this is very important for governance and for reuse. And just one important component of state file that perhaps Josh is going to talk in more details is that if you're starting with Terraform, just executing in the command line, the state file is going to be created and stored locally. But once you start collaborating with others, people that want to participate in the same deployment, they need to have access to the state file. Then you start going to the issues of where to store the state file in a shared location that people have access, and how to manage the concurrent accesses to that. And that's when we start going to the different backends, and that's when a Terraform Enterprise might make sense in some situations. And this is just about the life cycle of the Terraform, an infrastructure managed by Terraform. So whenever you execute a plan or apply, you're going to get an output with the expected changes, if any. And this output is either going to say create resources, destroy, replace, or update in place, depending on the reconciliation that Terraform does between your code, the existing infrastructure, and the state file. So those are the 3 components that define the execution of the lifecycle. And then I think to wrap up my section, just some very important points. So the first one is that point about credentials. And the reason that we stress this is because more than once it has happened that organizations, developers start using Terraform, and then they store this code on GitHub, but they hard-coded their credentials, and that goes to GitHub. And there are bots and hackers and organizations that are reading GitHub repos, looking for those API keys. And if they find, like, it's very quick and they start Bitcoin mining or whatever. So please, either use environment variables, or there are other more advanced approaches. Terraform Enterprise has some solutions, but please never hard code your credentials. About mutable and immutable infrastructure, Steve mentioned briefly. So just to say that Terraform has this immutable paradigm, and I think Josh is going to talk about Packer. So this idea of creating images, especially for your VMs containers, like it's clear, but for VMs, Terraform considers, like in the ideal world, companies will be creating images and just deploying these images. So you define your infrastructure and you specify the image that you want deployed. However, HashiCorp understands that not every organization lives this in this reality. So there might be workloads that still need configuration, that's maybe long-lived servers. So Terraform can create the VMs and call some configuration tool, be it a bash command, a chef, or Puppet, Ansible, whatever. So Terraform is flexible enough to support those too. But this link, I think we're going to share the presentation, is a really cool whiteboard session from Armon Datgar, one of HashiCorp's founders. And he explains like this distinction and talks about variability. Like, it's super cool. I highly recommend. We can talk more in the session afterwards. And finally, when using modules and when using Terraform providers as well, it's always a good practice to tag the version that you're using to make sure that if there are changes in the future, like your code will remain functioning. Thank you.
All righty, awesome. Thanks so much, Stenio. I guess that transitions over into my section. So hey, good afternoon, good evening, everyone. My name is Josh Addington. I'm part of the solution engineering team at Hashicorp, based here in Dallas, Texas, fairly close to Southlake, so close enough that I can attend today's meeting anyway. I've got a couple of minutes, a couple of slides here just to walk you through a brief discussion about maybe what day two operations looks like with infrastructure as code in a Terraform context. And then I also have some slides on what we're calling beyond infrastructure as code. And the reason I wanted to talk about that is because there's a number of other HashiCorp projects that exist that solve different challenges that you might run into if you're migrating workloads into Google Cloud, for example. And those tools may be able to help you. So I want to make sure that you're aware of them, number one. And number two, there's a broad everything as code approach when it comes to HashiCorp tooling. So I think that you'll find there's a lot of similarity there if you're familiar with infrastructure and code as code in general, or if you're familiar with Terraform specifically. I think you'll feel right at home with some of those other tools. So just real quickly, we'll run through my options here. And again, we've got some conversation time in the networking piece and the Q&A piece at the end of today's session where we can go deeper in anything here that Steve discussed or Stenio or myself. So we're happy to do so. But I wanted to throw up just a couple of helpful hints that we see a lot of our customers and a lot of our community gravitating towards once they're using Terraform on real life infrastructure that has applications running on it. Now, the first of them is just the Terraform validate command. So this is a piece that's built into the tooling, so you can run Terraform validate. It'll comb through your working directory and look at all of your .tf, all of your config files, and make sure you don't have any syntax errors. So if you're running Terraform in some kind of automation context or with a pipeline, it's really helpful to catch some of those things that can throw a wrench in the machinery later on. If we want to get even more mature than that, there's a number of other community-based tools, something like a TerraTest or TF Linter that can, one, analyze your code, or number two, even run some tests, and you can get the results back from that. And you can build test cases that are fairly complex to make sure everything's working correctly. There was some pretty broad conversation with the Terraform community over the last year, 18 months or so about this kind of capability. So I'm happy to report, kind of keep an eye on Terraform 1.2 release notes. You may see some great enhancements in that area with official support from HashiCorp. So kind of watch this space. Next up, and Stenio mentioned this, and Steve did as well, part of your Terraform workflow, anytime you're running our tooling, you're starting with a Terraform plan to do that dry run. And one of the things that you get is the ability to output a plan file. It's a detailed list of all of the steps that Terraform is going to take, what resources are going to be created, what existing resources are going to be changed, or maybe even what existing resources are going to be destroyed and removed out of Google Cloud. You can take that and do some amount of drift detection, because if you're not actually trying to change anything in your code and you run Terraform plan and it tells you, hey, Josh, we're going to be deleting or changing or moving stuff, that means that somebody must have gone in through some means outside of Terraform and made changes to that infrastructure. So you can get kind of alerted or brought the drift brought to your attention so that you can do something about it. So we see a lot of customers kind of digging into the Terraform plan, running speculative plans on a schedule to detect drift and other things like that. There's also a notion, as organizations tend to get broader adoption of Terraform, you might have resources that were built in Google Cloud outside of Terraform. So we do have a built-in import command as well that allows us to kind of suck up existing resources and create a Terraform state file for them. Now, one of the things, and especially if you're familiar with Terraform, you might already know this, state is only part of the equation. This is an infrastructure as code tool after all. So the Terraform code that represents the resources that you just imported into your state still needs to be authored. And there's a process going, kind of ties in with the Terraform plan step above, where you build your code, you make your tweaks to represent those resources you imported, you run Terraform plan, and when you get back the fact that there's going to be no changes made, you know that everything matches, and then you continue on in a normal Terraform infrastructure as code workflow from there. Now, you also heard a little bit about state file management, and this becomes even more critical over time. This is something that Stenio mentioned. The state file is absolutely critical, number one, to the function of Terraform, because that's one of the key data sources that it uses to evaluate that plan and tell you exactly what it's going to do differently. Deltas in that state file over time can be super important to look at from an operational team standpoint. So a couple of times we've mentioned the fact that there is a commercial version of Terraform, what we call Terraform Enterprise. It's available in 2 different flavors. You can do a self-hosted install of it. We also have a SaaS version called Terraform Cloud as well. Both of those solutions handle state file management very elegantly. It lets you store those states. It presents a visual diff of those states so you can kind of go back and see the history of it. So definitely something to consider if you're using Terraform or thinking about it in the future. How you manage your state files and state file access is absolutely critical. The next step, what we call workspace management, kind of has 2 different meanings depending on if you're using community Terraform locally on a workstation or in a pipeline context, or in the enterprise products as well. But this is the notion of all of the componentry that you build together. So it could be your local working directory and how you have your list of variables and your set of Terraform core code, and then your Terraform modules that might be added into there. When you scale up the size of a team or the size of an organization that's using the tooling, controlling what's allowed to live within that workspace becomes very important. There's ways to do it from a process standpoint. There's also some solutions that enterprise product brings to bear there as well around access control and around this notion of modules that we talked about, which I think is critical here. So modules that are freely available, anybody can create them. You can take one big TF file and you can break it into smaller chunks, or you could source material from the Google repository that Steve mentioned, or from the Terraform public module registry as well. But in the enterprise product, you can host those, you can curate them into what we call the private module registry. So, Jim was talking about Sabre earlier, so this could be something where Sabre hosts their own internal collection of approved and vetted modules that can be used by the organization. So that capability exists as well. The final point on here, and again, something Stenio brought up, the concept of immutable infrastructure. So this is where we're treating our resources more like cattle, less like pets. This is where we stand up a server. It has a defined lifetime. When we're ready to roll out version 2 of our app, we're going to stand up a whole new set of infrastructure. We're going to run our tests and make sure everything's working well. And then we're going to run Terraform destroy to wipe out version 1 of that infrastructure. So there's not a notion of upgrading software in place or upgrading servers or resources in place. Instead, we're creating new, verifying everything is okay, directing traffic over to the new version, destroying the original ones. I'll put in my tips as well for watching that video from Armin. So I do understand that this deck will be shared with everybody, so you'll be able to get that link. It's just a fantastic discussion about the philosophy behind that kind of approach. So hope that is useful to some folks. And again, we'll do more when we get to the Q&A and the networking portion later on. So for anyone that may or may not be familiar with Hashicorp, I wanted to throw this slide up before we get to some of those other tools and other everything as code examples. The 8 projects that you see over on the right-hand side there are all of our open source projects that we manage and maintain today. A handful of those have enterprise versions as well. That's what my team is responsible for. But we're going to focus on all 8 of those tools, just so you get an idea of what they are, what they do, and if they could be potentially helpful to you. The first of those, of course, is Terraform. We spent plenty of time talking about that, so I won't belabor that point anymore. If you're looking for any more information about Terraform or any of these tools, I tried to put the project links in the bottom right-hand corner of every slide, so you can always hit terraform.io in this case for more information there. So the second tool we'll talk about is called Vagrant. This is one of the oldest tools that we have in the stable here at HashiCorp. Vagrant, I call it a tiny Terraform. It's all about defining through code what a single virtual machine looks like and being able to stand that virtual machine up repeatedly in an identical way. You can do that on a local machine for development, for testing. You can do that in the cloud as well. So I've got an example here. This is a Vagrant file that just stands up a GCE instance using a very defined workflow and pattern. So this is something that you could share across a team, again, if you're trying to do development across a common environment, or if you're trying to do QA or testing across a common kind of landscape. It can certainly help with that. The next tool, Packer, is our automated image creation tooling here. And you can think of it as images as code. We've got some great enhancements that have come to Packer over the years. Again, it's one of the older tools here at HashiCorp. There's a SaaS version of it now that collects metadata and exposes it for use in Terraform runs, which is really exciting. But this is an example of what the under the hood code, a Packer file, if you will, can look like, where we're just very specifically defining how this virtual machine is going to be built, what the source image is, any changes that we need to make to it, and then ultimately how and where we're going to build it to make it available for use in provisioning tools like Terraform itself. Next solution is HashiCorp Vault. This is our secrets management solution. So it's designed to help you securely, safely store secrets, generate and sign certificates, perform cryptographic operations, all kinds of cool things that Vault can do. But under the hood, kind of you're guessing the pattern here, there's a lot of codified documentation that takes place. So this is an example of a Vault policy. It's in that same kind of HCL format. So it's easier to read JSON, easier to read YAML kind of format there. Still efficient for the machine to process, but fast enough for us as humans to write it, and maybe more importantly, to read it and to interpret it. So this policy is just dictating what an individual user, machine, persona that logs into HashiCorp Vault is going to be able to do at a create, read, update, delete kind of level for policy. There's another tool. This is one of the newest ones that we have. So this is a community project we announced a little over a year ago. HashiCorp Boundary is all about secure remote access. So granting a human user a secure connection into remote hosts or databases or services. And just like these other tools, there's a notion of code documents underneath the hood. So this one's a little bit different. This is actually a .tf file. So if you're familiar with Terraform, you know this, hey, this looks like Terraform resources that are being built here. Well, we have providers for most, if not all, of the HashiCorp tools that exist out there. So you can use Terraform to define and build and control your rollout of HashiCorp Boundary and do that in a very codified way. And again, in this example here, we're building a user and kind of binding it to a role and a scope within the Boundary product. The next one here is called HashiCorp Console. This is our service mesh product. And the whole idea behind Console is to be able to connect and secure the communication between workloads that might live in multiple public clouds and or your private cloud environment as well. Console under the hood, just like you guessed, has some configuration files, has some codified elements that we can use here. This is just instructing the console binary to act as a server and to follow a certain set of behavior that we specify there. So a fairly simplistic example. We've also got HashiCorp Nomad. Nomad is our flexible orchestrator. So it can do some pretty popular things like deploying and orchestrating containers, but it has an extra trick up its sleeve. It's got the ability to orchestrate deployment and kind of get a little bit of containerization strategy benefits for legacy applications and other workloads. So these can be things like an actual virtual image. It can be a raw executable. It can be a Java jar file. So all these things can be scheduled across a fleet of resources, just like containers can. So it's a pretty exciting technology. And just like other schedulers that you might be familiar with, you can define a job file or a job spec file like this one that you see right here, which again is going to help us define what job we want to run, where we want to run it, all in a codified way. Just like you would expect with Terraform, all of these documents, all of this code can be loaded into version control, can run through a process of review and approval, and then of course can be pushed and executed once all of that is done. The final project, and again, one of our more recent announcements, a little over a year old, is Hashicorp Waypoint. This one's pretty exciting too, because it's all about build, deploy, and release automation across different stacks. So take any kind of code or runtime that you're working in and be able to deploy that to any kind of development. Also codified. I had to split it into two columns here because it was a little bit long. But in this case, you can see we're taking a Node.js project, and we're actually going to be running that in Google Cloud Run, deploying it in Cloud Run. And you can see an example of what the codified deployment, build steps, etc., is actually going to look like to do something like that. So again, the point of the last few slides was to show you guys that, yeah, infrastructure as code is always a great place to start. And it's where a lot of people get introduced to the HashiCorp ecosystem. But these same kind of thought processes, where we talk about codifying everything, making it self-documenting, checking it into version control, and going through this GitOps style of process, it's pretty prevalent across our entire stack. And if I didn't mention at the very beginning, the whole point behind all of these HashiCorp tools is to help you add control planes, right? Control points to all of these different challenges that emerge in complex cloud networks, like we're all working in here today. So there we go. That's my last slide. So I'll back out of the presentation here. And apparently I've been signed out, so just in time.
All right. So is that is your last it's your last slide, Josh? Is that the last slide of the entire thing?
I think so. Guys, correct me if I'm wrong, but I think so. Yeah.
All
We
right.
have additional content if needed, but the idea was more to have like during the open discussion, and if needed, we can bring it.
Yep. No, I just wanted to double check because you know, with the three presenters, I know Josh was running the slides. Just wanted to make sure before we move into the next section, the Q&A. And we did have some questions from Salah. It got answered in the chat. But just for those who on the recording, we won't we won't be able to see the chat. So the question, and so if you don't mind answering it again, it may not have to be as verbose. But the question was, when you're doing infrastructure as code, if you start with infrastructure as code right away from the very beginning, now you have scripts for all of your infrastructure for your entire environment. But what happens if you've been running for a year in Google Cloud or another cloud, and you've been using shell scripts or something else to build the environment, and now you're like, hey, what, this Terraform stuff looks great. I want to start using that to build my environment. What happens? Now I have part of my infrastructure that Terraform doesn't know about. What should I do? What are the options?
Sure. So I'd love to take the first stab at that one. I'm sure Stenio has some input as well, and Steve. So I mentioned this briefly in my part of the presentation, the fact that there is an import capability with Terraform. It's not definitely not a silver bullet. It's not a magic solution for bringing in existing resources, but it will take a project, a VM, any number of resources that you pointed at, and bring them into your state file. The state file is only half of the battle. So like I mentioned, Terraform is all about infrastructure as code. At the end of the day, we have to have a code document that represents the resources that ended up in that state file. So your choices are then to either start authoring that from scratch, or hopefully you have some form of organizational standards, architecture standards, what have you, that defined that resource that was built outside of Terraform in a standard way. And it becomes pretty easy, if not programmatic, to actually document it as code and move through that step. So it is a level of effort, but it's usually not overly complicated or overly complex, depending on obviously the environment or the resource that we're talking about here. But fear not, there is a process and kind of a best practice way of going about it. As you guys can imagine, pretty much every company out there started their cloud journey without Terraform. And so they all have these brownfield environments that they're trying to figure out what to do. So this is not really a new problem, and it's certainly not unique to Terraform or infrastructure as code. When development environments change, runtimes change, programming languages change, we all have to decide, okay, where do we draw the line and how do we move forward? So I think it's just another one of those inflection points And I think that it's key for an organization to have a strategy behind that and how to execute and move forward. So.
And I think strategy is the key word there. So just to add a little bit more, yes, Terraform has this import functionality, but also be mindful that Terraform is not a magical solution. It doesn't exist in a vacuum. It's ideally part of an overall infrastructure as code strategy and journey that the company embarked. So that's what I mentioned in my answer. Usually companies that are starting with existing infrastructure, they can decide, okay, from this day on, our new infrastructure will be codified with Terraform. And eventually, as time allows, as priority makes sense, they can start going back and doing these imports. But ideally, is this journey that they're embarking, and gradually things start getting into this more codified and immutable.
You know, and something to think about too is look at the organization itself. So some of like your cloud native organizations, you know, they try to build, hey, every individual app team gets their own VPC. We'll figure out how to bind them all together and kind of create that full mesh. But the idea is the purview of the individual VPC is something that the entire application team is responsible for. So in scenarios like that, absolutely, you can have one team that's using infrastructure as code and then another team that's not, because your purview is your individual VPC. But in other large organizations where you have more of a centralized IT and then app teams kind of bind in, that's where you really have to be cognizant of kind of like the gateways to prevent that configuration drift from happening. So you have to also look at your organization specifically to try and understand what makes the most sense for me in my scenario.
All right. No, thanks for that. Yeah, I think it just it reminds me back. This is like a 20 years ago story. Working on a product. You know, I don't know how many long we were working on it, but it was a Java application with an Oracle database, and so we had a development environment with the application and the database, and that database started, that schema would just get snapped and start getting installed at customer. And so we're like, well, how are you building that database? Oh, I'm just snapping it in time. Well, how do you match up the application code with the database? So we had to go back and write scripts to build the entire database, and then from that point forward, any database changes, apply a script, Immutable, you could run, and if that new thing was already there, to not build it again. So it was. It sounds like same type of problem, but now on a bigger scale, because now I'm dealing with VMs, clusters, GKE clusters, or whatever Kubernetes clusters, that I have something that exists, but now I want to be able to install. Say I had an emergency, I need to build the whole thing again in a different region. How could I do that? I'd have to go back and kind of fill in the gaps with that old stuff, write the scripts that kind of equal what I already have. All right, I'm going to flip over to the Q&A. There was a question that says it got answered. I can't remember. You might have already answered it, but we'll do it for those that are catching up on the recording. It's from Gaurav Dagra, one of our organizers. Are there any plans to enhance Terraform to programmatically capture failures if the apply fails, for conditional executions? So I guess maybe how to handle failures programmatically. Maybe maybe it really doesn't handle it now, or maybe it does. I don't know if the details, but go for it, Josh.
Yeah, thanks, Jim. So let me make sure I understand the question first. So I'm interpreting it as current behavior, the Terraform apply fails, then you're kind of left in this weird state. We don't know exactly what was done. Extra steps aren't going to happen. You might be in a partial state. It doesn't have a graceful way of saying, oh, well, I deployed half of it. If this doesn't work, maybe I try this, or maybe I try some other resources. So you can get some unexpected behavior in the event of a failure. Let's
take it like that. Unless Gaurav types something more into the chat, just take that as the context, and then we'll change the answer if there's feedback that comes in while you're talking.
Yeah, sounds good. So the short answer is no, I'm not aware of any changes to the way that executes. Part of it comes from the broad strategy of Terraform. We use that word declarative. So we're building a document that says this is what shall exist when Terraform is done. We don't necessarily want Terraform to make decisions on your behalf or say, well, I got an error and I wasn't able to do X, so I'm going to do Y as the next best thing. So I don't know that we will take it down that path beyond trying to make error messages as clear as possible, trying to feed that back to a user that's interactive in a terminal or to a pipeline tool that's running it in a context and just streaming that back to something. I suspect that will be the strategy that we take.
Okay. Would that be a scenario where it looks like Garv said that's it. But on a scenario like that, would and I've heard of companies having something like Terraform for the infrastructure, and maybe another tool like Ansible or Ansible Tower.
Yeah.
Would Ansible Tower be able to be that brain to catch the error and then decide? You can have pre-decided what to make Terraform do next.
So maybe so. The most common pattern that we would see, you have an error on apply that was not an error on plan. Typically, the next step is Terraform destroy. So let's remove whatever did get created in a partially complete state.
Sure.
So let's make sure that we've cleaned that out, and let's go determine the source of the error. Did we do something wrong? Did we feed it an improper value? We're trying to build a resource in a Google Cloud region that doesn't exist. We have something like that. Or is there a bug in the Terraform code and we need to go submit a GitHub issue if we're a community user? We need to go to Hashicorp Support if we're an enterprise user, that kind of thing. So you usually take that kind of step. An orchestrator, I don't know if Ansible would be one, but we commonly see things like Jenkins or other CI/CD pipeline tools running Terraform in a context. Okay. And it might run Terraform as one step to stand up a VM. It might run Ansible to do some birthright provisioning, install software, install patches, do that kind of thing on the VM once it's live. So that's a pretty common step that we see. What they may do is insert into that playbook or into that the pipeline step. Maybe there's a try-catch error you can do. Maybe there's something interesting that says, hey, if the Terraform apply errors, then let's go ahead and automatically run the Terraform destroy, and let's create a task, send a notification, do whatever's necessary to go back to the team that triggered this and say, well, hey, something came off the rails. We need to investigate.
I can share my 2 cents quickly. In my experience, those situations where you have a Terraform plan that's successful and then you do a Terraform apply and something unexpected happens and Terraform just stops, usually that happens when you have complex Terraform code. It starts to get a little bit long, or you're importing things that maybe you don't have as much knowledge of what's going on and you're just trusting, and then these unexpected behaviors happen. So my recommendation usually, try to keep your Terraform code simple and try to benefit from using modules. So the idea with modules is that you can condense pieces of information in these modules that work, they're proven and tested, and then you can just have this modularized Terraform codes that that it works. So especially when you're talking about an organization context and talking about governance, eventually you're going to have different roles within the organization. So it's very common to have the cloud architects to be responsible for being spearheading the effort, and they start defining, oh, these are certain modules that we have tested, they work, and these are the modules approved for our developers to work. So the developers don't have to start from scratch, and every developer is doing whatever they want. They start leveraging these existing modules, and then you reduce the likelihood of these unexpected situations to happen.
Yeah, and another piece to talk through is, instead of just a Terraform destroy, so say I'm deploying something in prod and wanting to go from 4 VMs to 5, for whatever reason it didn't work. Instead of Terraform destroy, look at the versioning of your Terraform code. So instead of deploying or trying to destroy what was partially implemented, let's try to deploy my other version to not necessarily take as much of a downtime in a scenario where I'm trying to deploy in prod and there's going to be impact to users, things of that nature. So that really comes back to the conversation about versioning, and when something bad happens, what are my next steps? is it going to be complete destroy? Am I going to try to apply a different version of my code that is solid and I have tested and it was deployed? So more things to keep in context in regards to that. But I think to kind of transition to a different perspective of Grav's question, what about if I had in my Terraform code a bash script that kicks off? And I think that that's a good conversation to talk about. Here are aspects where Terraform does really well, but here's aspects where your Ansible is going to do really well, where Chef and Puppet are going to do really well. And I think that the key piece being is Terraform will kick off a script. But if there's errors in the script or things like that, it's going to say my job was to kick off the script and my job is now complete. So depending on the criticality of that script, that might be something where Terraform might not be the best use case. It might make more sense to bake that into the image itself that Terraform calls, or to leverage something else like Ansible to actually deploy that startup script so you can get more verbose feedback to understand, did this apply correctly or not?
Mm-hmm.
Yeah.
All right, and Garv did type some extra, and then I'll go back after that. I'll go back to Wence's question, and you might already had it, and you might already answered it, but it's that Ansible has try-catch is what they're using now, and he was just wondering if maybe on the Terraform roadmap if it would have some kind of functionality like that in future. The answer could be no, but.
Yeah, it's nothing that I've seen explicitly stated. I'll go back to that very cryptic comment I made about the future of a Terraform test command.
Yeah.
That may help with some of those scenarios.
Well, actually, there's something that can do that. So Terraform Enterprise, what's the name of the workspace dependencies? So
triggers.
Triggers,
Run triggers. Yeah.
Terraform Enterprise, each deployment you can track as a independent workspace, and for each workspace you can assign user permissions, you can change variables, etc. So it goes into the governance features that Terraform Enterprise offers. And one of those features is that you can define one deployment is dependent of another. Mm-hmm. So first this deployment runs, and then it triggers the execution of the following one. So that
So if one was dependent on another one, if this first one fails, it won't even trigger kicking off the other one because it failed.
That's correct.
All right, so I'm going to slide up the chat for Wences Michelle, and I forgot to give a shout out at the beginning because we do have some of the HashiCorp user group members have from DFW have joined. Kind of a they're here, and so this question is from Wences, who organizes that group, and for playing the role of newbie, managing state files, when transitioning from local to state to cloud state. Is there, I guess, some general question around the state files, and even you can even maybe take it as if you're moving from the free open source version to the enterprise version, and is there a transition path or is it seamless? How does that work?
Sure. So Wentz, it's good to see you again, my friend. So to tackle the question directly, you can easily transition your state from one storage backend to another, from having it local on your workstation to putting it in a shared remote backend to putting it in Terraform Cloud or Enterprise and back again in any number of combinations. The caveat is your state, you got to kind of treat it as a sacred file. It can only live in one location at a time. So you don't ever want to end up in a place where you have two copies of the state file. One's been updated and one hasn't. Which one is correct? Ooh, that's tough. So there is a migration path, and it's pretty simplistic. Anytime you run Terraform init on a machine, it's going to review your Terraform files, and you would configure the remote backend that you're using for your state storage. As part of that, we recently added with either 1.0 or 1.1 of Terraform binary, kind of a new and updated way of managing that. So it gets away from just the backend config, and it gets towards an actual cloud block that you define. you point to a Terraform Cloud instance, you point to a Terraform Cloud workspace. You have a couple of different mechanisms for supplying the credentials that are necessary to auth to it. But then when you run Terraform init, you'll then be prompted as the operator, hey, do you want to migrate your state from local to the remote, to the cloud backend? Say yes, and it moves. You say no, and it doesn't. Same process works in the reverse. If you were to remove that remote backend config and then run Terraform init, it will say, hey, you're trying to pull the state down, and it will pull the state down. So hopefully that answers the question.
I think it's important to know that the cloud state storage, it's available for free. So it's similar to using Docker Hub, that you create your Docker image and you send to Docker Hub, like it's over there, like in the cloud. So the Terraform Statify is the same thing. So there's it's considered open source. It can be local, it can be on a S3 bucket or object storage or a SQL server. It can be the Hashicorp Cloud, or it can be the enterprise version that it has like the governance features. But just to have this clarity that you can use cloud for free as well.
Yeah, thanks for that, Stenio. That's a great point. Absolutely true.
All right. Unless there's some more questions that come in the Q&A, I do have one question I like to ask presenters. And this will so this might be the final question, and it's not tech related necessarily. It's career related. So if you could go back in time and give some advice to your younger self at the start of your career, what kind of advice would you give yourself? And I don't know who wants to go first.
I'll take that one. I kind of alluded to it initially. Hey, I wanted to go into networking. Why? Because, man, I could do a lot of research and I only have to do this one line of code for actual work. In hindsight, stick it out and learn the coding up front, because your life becomes immensely easier with it. It was a lot more challenging to learn coding with a full-time job, trying to apply it, as opposed to when I was in college, picking it up from the start there.
All right, so you tried to get into tech shortcut without learning coding. But let's just learn it anyways. It'll help you whether you're on infrastructure or actually writing applications that you're selling. All right, thanks, Steve. Josh, do you want to go next?
Yeah, sure. I'd be happy to. I think I would want to tell. Well, aside from just telling my younger self, maybe a few stock tickers to watch and invest in. I would say that practical hands-on experience and certifications is every bit as useful and important as like college degree work.
Yeah. And
maybe to focus on some more practical application stuff earlier to round oneself out. Okay,
you get that. So just having the head knowledge, can I actually put this into action? Sure. And prove I can. Well, I don't know if it's not necessarily prove you can put it into action with certifications necessarily, but you do have to know more of the, this individual product. Like if you're learning cloud, I need to know all the solutions, how to stitch them together, that sort of stuff. So that, thanks for that, Josh. Stenio?
Yeah, and for me, I will build on that by saying, learn how to learn by yourself. So with IT, we always need to be learning something, but if you have to depend on paid classes, it's going to get expensive pretty soon. So be comfortable exploring knowledge on yourself and develop the skill to have the focus of, like, you start studying something, like set a goal and set some time, like every week or some sort of cadence to make it recurrent so you can achieve that goal in a certain timeline. So this is a very important skill for anybody in the IT field, and it's going to save you a lot of money.
Actually, to that, I've been really impressed with Hashicorp's self-paced training. I thought that was just well put together and very easy to follow. And in a world where scheduling training with different customers can be challenging, and then there's finances involved, hey, here's this link. It's on your own time at your own pace, and it's very well put together. So that's been something cool that I found specifically towards this conversation to complement that, Stenio.
No, it's finding the quality things to learn on your own, and kind of sticking with it. All right. So seeing no additional questions, we do have some great sessions, and thank you for presenting. So we'll definitely say that again. Thanks for joining us, Steve. Thanks for wrangling Josh and Stenio. I'm going to give you the golf clap. Can't clap too loud, it'll blow out the microphone with the golf clap. Thanks for joining.